Today we're going to be looking at the perimeter and area of squares and rectangles and the segment addition postulate. So area of a square or rectangle is going to be base times height. And when we're talking about area, the units are always going to be units squared. So if it's inches, it'd be inches squared. If it's meters, it'd be meters squared. Perimeter is all around. So you have two base lengths and two of your heights. So the perimeter is going to be 2 times the base plus 2 times the height. Or you can just add up all the sides together. So the units for this is just going to be the units. So if it's inches, it's inches. If it's yards, it's yards. So let's look at some examples. A landscaping company is hired to install sod and fences when a new houses are built. Rolls of sod and sections of fences can be ordered to fit any size or shape yard. Below are sketches of yards. How much grass is needed for each yard? How much fencing is needed for each yard? So let's start with the grass. The grass is going to be all the inside, which is our area. So we are going to be using the formula area equals base times height. So our base is 4 and our height is 3. So we're going to do 4 times 3, and 4 times 3 is 12. We cannot forget our units. Our units are going to be yards, but it's area, so it'd be yards squared. Now let's look at fencing. So fencing goes all the way around the yard. So we're going to be using the formula for perimeter. So perimeter equals 2 times base plus 2 times the height. So 2 times our base is 4, plus 2 times our height, and our height is 3. Now let's simplify. 2 times 4 is 8, plus 2 times 3 is 6. So we get 8 plus 6 is 14, and then our yards for our unit. Let's look at the next problem. We have to find the area of the grass, so how much sod is needed. So we're going to take the area formula, so base times height. So base times height, we have 7 for our base and 7 for our height. So 7 times 7 is 49. Our units, yards squared. Now for fencing, it's going to be the perimeter all the way around. Since we have a square, we only have one length, and it's the same all the way around. So we could do area is equal 4 times the base. So we would have 4 times 7, and 4 times 7 is 28. And this is yards. And I said area, and I meant the perimeter. So the perimeter we're going to have as 4 times the base. Okay. Let's look at the next problem. Mrs. Thomas bought a new rectangular area rug for her dining room. We need to find the area of the rug. So area is the inside. So we have to do the formula of area equals base times height. So our base is 3 and our height is 6.5. We are going to multiply. So when we multiply this, we get 19.5. So the rug, this area is 19.5 feet squared. Now we need to find the perimeter. We need to go all the way around the rug. So we are going to use the formula. Perimeter equals 2 times the base plus 2 times the height. And the base is 3, so 2 times 3 plus 2 times our height, which is 6.5. 2 times 3 is 6. 2 times 6.5 is 13. 6 plus 13 gives us 19. So the perimeter of the rug is 19 feet. Okay, now let's look at the segment addition postulate. So in the diagram, we have points P, Q, and R. P, Q, R, and S. And these points are collinear. Collinear means on the same line. So we have the length of PS is 46, PR is 18, and PQ is equal to QR. We need to find these lengths. So let's use this information that's given. So these three are collinear, they're on the same plane. So PS, this whole section, is 46. PR is 18, so from here to here is 18. And then they tell us PQ is equal to PR. So PQ is the same length as QR. So we're going to use these little markings, and that's going to say they are congruent, they are equal. So let's find these indicated lengths. So PQ, from here to here. If this full thing is 18, and we have two sections, we're going to divide it by 2. So that makes this 9 and this 9. So PQ is equal to 9. QR is also equal to 9. Because both of these, when you add it, it's going to give us our 18. QS, Q2S. QS is going to be equal to QR plus our RS. It is also the same as PS minus our PQ. So whichever ones work, we can figure this out. So it's going to be easier to look at PS minus PQ. We have the full length of PS, and we know what PQ is. So we're going to do 46, which is PS, and then the length of PQ is 9. So 46 minus 9 gives us our 37 for our length. Now let's look at QS, or RS. So we need from R to S. So we could take the full length PS and subtract PR. So the full length is 46, and we subtract PR, which is 18. That gives us the length of RS, which is 28. Okay, let's look at some examples down here. For these 4 problems, we need to find BC. So we have our full length A to C is 15, and then A to B is 5. So this is going to be the difference of these two. So if we do 15 and we subtract 5, we get 10. So 5 plus 10 gives us our full length of 15. Okay, we need to find BC here. So we have AB, which is 4, and the full length is 16. So if we subtract them, 16 minus 4, that gives us 12. So 4 plus 12 is our full length of 16. Number 3, we have our full length of 20. Part of it is 14. The other part we need to find. So 20 minus 14 is 6. The last one here, we have the full length of 30, and part of it from A to B is 18. So if we subtract the 2, we should get our BC. So 30 minus 18 is 12. So now let's go one step further with this. Instead of just working with numbers, we're going to be working with expressions. It's the same process. So we need to find VW. So we need to find this length here. So we have the full length, and we have two partial lengths. So we know TV plus VW, so TV plus VW is going to equal our full length of TW. So TV is 3x, and if we add x plus 8 for our VW, we're going to get the full length of 32. Now let's solve this. Our like terms, 3x plus x gives us 4x plus 8 equals 32. Subtract the loose number, so subtract 8 from both sides. We get 4x to equal 32 minus 8 is 24. We have 4x, so that's multiplication. We have to do the opposite and divide both sides by 4. And we get x to equal 24 divided by 4 is 6. So we found x. X is 6. That's not answering the question. We need to find VW. So we need to find this length. We know VW is x plus 8. We know what x is. X is 6, so we're going to substitute it in. So 6 plus 8, 6 plus 8 is 14. So our answer is 14. This last one here, we need to find YZ. So we need to find this length here. We know XY plus YZ is equal to our full length of XZ. So let's substitute in each section. So XY is 2x plus 3. We're going to add that to our YZ, which is 3x minus 1, and this full length is 27. So we need to combine our like terms. 2x plus 3x is 5x. 3 minus 1 is positive 2, so plus 2, and bring down our equal to 27. Our loose number is plus 2, so we're going to subtract 2 from both sides. Bring down the 5x is equal to 27 minus 2 is 25. 5x is multiplication, so we divide both sides by 5. So x equals 25 divided by 5 is 5. The question was asking for yz, not x, so we have to go back up. So yz we know is 3x minus 1. And we know what x is. X is 5, so substitute it in. So we get 3 times 5 minus 1. 3 times 5 is 15. Subtract 1 and we get 14. So that is the lesson for finding the perimeter and area of rectangles and squares and the segment addition postulate. Please reach out if you have any questions.